Thornthwaite classification. An American climatologist. Always you have German and American counterpart in that period. Thornthwaite. C.W. Thornthwaite. He believed that climate may be regarded as expression of energy, as an expression of energy and water budget. Now he has classified 1931, 1948 and 1955, several minor classification in between also, but major included is 1931 and 1948. So you may be asked separately 1931 classification, 1948 classification. Now what do you mean by energy is associated with temperature, which is basically a function of latitude. Insolation is a much bigger term, right? Right? And water budget is basically a function of precipitation, yes. So by combining these two, he introduced a term called potential evapotranspiration. What do we mean by evapotranspiration? I hope you understand. Evaporation plus transpiration. Potential means if these were available. Potential evapotranspiration. If any area has sufficient amount of moisture, then how much evapotranspiration would take place in that area is potential evapotranspiration. Did you get that? Right? So it is basically associated with soil moisture balance. If all the pores of soil is filled with moisture, it will encourage waterlogging. As simple as that, right? So that's the balance, that's the end limit when it is saturated. So that will basically a function of again precipitation and temperature. For 1931 classification, he used thermal efficiency and precipitation effectiveness. As the basis to identify climatic regions. And through the quantitative techniques, he found thermal provinces and precipitation provinces separately. The 5 thermal provinces or 5 humidity provinces first. Total 5 in numbers in 31. A per humid with precipitation effectiveness index more than 127. The vegetation types is rainforest. B humid 64 to 127 forest. C subhumid 32 to 63 grassland areas. D semi-arid 16 to 31 steppe. Then E arid less than 16 desert. So that is precipitation effectiveness index, easy to remember. More than 127, keep on doing half, roughly. 64 to 127, 32 to 16, less than 16. Then he identified 6 thermal provinces. Thermal provinces. He used the letter A dash. The same word by megatherm, thermal effectiveness index, again 127, B dash, mesothermal 64 to 127, C dash, microthermal 32 to 63, D dash, taiga 16 to 31, E dash, tundra 1 to 15, and F dash, frost 0 and less. So if you look at 5 humidity provinces and 6 thermal provinces, you can have 30 climatic regions. AA dash, AB dash, AC dash, AD dash, this way 6 into 5, 30 climatic regions, right? This is the second basis. And third basis was seasonal variation in precipitation. Again he used similar letters, except F, he used the term letter R, rainfall throughout the year. M, monsoon. W, winter dry. S, again summer dry. Sorry, he didn't use the term M. He used the term D. He's used the term D. Rainfall deficient throughout the year. Here you have summer deficient, winter deficient, and deficient throughout the year. So 5 into 6 into 4, so 120 climatic regions can be found by combining all the thermal provinces, humidity provinces, and seasonal variation in precipitation. / 1948 classification. Four bases: moisture adequacy, thermal efficiency, seasonal concentration of thermal efficiency, seasonal distribution of moisture adequacy. All the four bases, you can write down please, all the four bases all the 4 bases are expressed through an index value to demarcate climatic regions. These values are used and quantitative application of all the value gives separate climatic regions. When adjustments are made for the storage of water in the soil, the monthly surplus and deficit of precipitation and potential evapotranspiration can be found. क्या लिखा सेंटेंस थोड़ा इनकम्प्लीट है शायद.
When adjustments are made for the storage of water in the soil, the monthly surplus and deficit of potential evapotranspiration.
Monthly surplus and deficit of moisture, can be found through precipitation and potential evapotranspiration. Can be found through precipitation and potential evapotranspiration through monthly moisture index formula. Moisture index formula, where Im is equal to 100 into S minus D by potential evapotranspiration, or Im is equal to 100 into P by PE minus 1. This formula, when soil moisture is assumed as constant, now earlier there was humidity provinces which were 5, right? Thermal provinces were 6. Now if you take into account the seasonal variation, so intra-regional variation can be found like per humid. It's fine that you assume a quantitative, take a quantitative data that find beyond this particular limit of rainfall, the area will be per humid. But the moment it comes to humid, there can be several zones, right? What is the quantity you take into? Like for example, if you look at the India map of climatic map of India, you have moist humid, right? Then you have subhumid areas. Then you have semi-arid. Even semi-arid, we have several types. The rainfall is 60 cm plus, rainfall is 100 cm plus, rainfall is 120 cm plus. But the same quantity of rainfall may not be useful for let's say temperate regions, because quantity of rainfall does not explain you about the vegetation types. It's associated with temperature also, right? Basic discussion we have already talked about that, how temperature and moisture precipitation combinedly tells you about the possibility of a type of vegetation in that area. That's how he has further classified into several groups. The first is, if you take it based on again moisture index,
So IM is
moisture index. A is equal to per humid. Then he has divided B into four categories: B4, B3, B2, B1. So all are basically humid provinces. In the per humid, again take 100. IM is 100. Then you have 80 to 100, 60 to 80, 40 to 60, and 20 to 40. That is the four provinces. Then he has classified C2 and C1, divided moist subhumid. That is 0 to 20. Then that's where the semi-arid starts. He has classified it into dry subhumid, minus 33 to 0. Then D, semi-arid, minus 66 to minus 33. Then E is arid. Then more than minus 66.67. So this is the moisture deficit area. All are moisture surplus. 4, 1, 5, 2, 7 to 9. So 6 he further divided into 9 provinces. Moist subhumid, dry subhumid. Minus 33 to 0, minus 66 to minus 33. हाँ, स्मॉलर होता जाएगा फिर वो. माइनस 66 लेस कितना आ जाएगा? माइनस 90. हाँ, तो नंबर्स में बढ़ रहा है या घट रहा है?
मैथ्स के हिसाब से तो गलत है, बाकी अपने हिसाब से सही है.
अपने हिसाब से सही है. तो देख लो वैसे ही, लेस देन माइनस 66. नंबर्स बढ़ते जाएंगे, मैथमेटिकली ये घटता जाएगा. हाँ, इसको चेंज ही कर दो. मैथ्स के हिसाब से लिखा जाए, जब मैथमेटिकल कैलकुलेशन है तो सही है. Second is again the same, based on potential evapotranspiration. Based on potential evapotranspiration, then we have precipitation effectiveness index. Again A dash, megathermal, precipitation effectiveness index more than 114. Then B4 dash, B3 dash, B2 dash, B1 dash. Again all these are mesothermal, divided into 4 categories. Starting with 99.72, 114, 85.52. Whatever problems we are facing right now can be the criticism of Thornthwaite. then 71 to 85.5, then 57 to 71.2. This is 4 provinces of mesothermal. Then we have C2 dash, C1 dash, microthermal. 28.5 to 42.7, 14.2 to 42.7 to 57, 28.5 to 42.7. Then we have D dash, that is tundra. Then we have E dash, frost, less than 14.2. Then we have 14.2, less than 14.2. Summer concentration of surplus deficit, moisture surplus, moisture deficit. Summer concentration of thermal efficiency. E dash, less than 48%. That means temperature roughly constant throughout the year. B4 dash, 48 to 51.9, B3 dash, 51.9 to 61.6, B2 dash, 61.6 to 68, B1 dash, 68 to 76.3. Then we have C2 dash, 76.3 to 88, C1 dash, more than 88. Then D dash, no value, E dash, no value, because very less temperature, especially in the tundra region and frost region throughout the year. With the negative value. Then we have seasonal moisture adequacy. Aridity index for moist climate. Basically A, B and C, especially C2, are no water deficit, surplus throughout the year. Aridity index 0 to 10. S, summer deficit, but not high deficit, not very high deficit. 10 to 20. W, moderately water surplus with a little winter deficit. Aridity index again 10 to 20. We further use S2, large summer deficit more than 20, W2, large winter deficit more than 20. Tundra and frost. उसका इंडेक्स नहीं दिया है, बहुत नीचे है. Then aridity index for arid climate. Humidity index, sorry, for arid climate. That starts with C1, D and E. D, little or no water surplus, that is deficit throughout. Humidity index 0 to 16.7. Then we have S, a little surplus during summer only. Humidity index 16.7 to 13.3, 33.3. W is equal to a little water surplus during winter, same. S2, moderate to large surplus during summer more than 33.3. W2, winter again more than 33.3. हाँ, S2 और W2 का सेम है, सीजनल वेरिएशन. May I? $33.3. More than 33.3. हाँ? एरिडिटी इंडेक्स है, कितना रेनफॉल होना चाहिए वहाँ पे, ओवरऑल एरिडिटी इंडेक्स और ह्यूमिडिटी इंडेक्स. That means what is the surplus level in that area. That doesn't have any quantitative counterpart. Again, is the value is derived from the respect to a formula in each of the provinces independently. So roughly index is that. अब आता है क्रिटिसिज्म और अप्रेजल, क्रिटिकल एनालिसिस. कैन यू मेक सम बाय योरसेल्फ? No. Much more data, figure. Chai brother. Huh? Yes, complex terminology. Don't you find anything very important and very good? About? Temporal variation. So whom it can be, this classification can be very useful. Meteorologist. How? Real time? No. Now you see that for what do you need when you are a meteorologist? Weather forecasting about the weather things. So does precipitation give you any idea about that? हवाएं कितनी तेज चलेंगी, तूफान के साथ आएगा या नॉर्मल आएगा, हेल स्टॉर्म होगा या सिंपल बारिश होगी, ठीक है, स्नो कवर होगा या क्या होगा. ड्राई एयर भी तो बहुत सारे तूफान मचाती है, ठीक है, साइक्लोन की कुछ बात नहीं हो रही है. तो जो द क्रिटिसिज्म विच वी हैव डन विथ रेस्पेक्ट टू कोएपन is almost valid here with respect to meteorologist. It is nowhere genetic classification. The moment we talk about genesis, that means we'll have to talk about all the ingredient, elements, factors which contribute in the formation or genesis of a climatic type in a particular region. Right? So it is more an applied.
Can be empirical also.
Empirical, purely empirical. Empirical and applied. So first thing is that not genetic, जितना भी क्लासिफिकेशन करना है उस पर क्रिटिसाइज करना है, प्योरली एम्पेरिकल, इनफैक्ट टू एम्पेरिकल एंड अप्लाइड, नॉट जेनेटिक. Right? Not genetic. Now the moment we say empirical and applied, here the quantification is too complex. Heavily loaded data and formula which makes it exceptionally suitable for, which makes it suitable only for the experts. Yes, water resources. The most important aspect is its water budget concept. Right? The concept of water budget is the most important contribution of Thonduvat in his 1948 classification. No world map can be drawn on 48 classification. However, a world map showing climatic regions can be drawn on the basis of 1931 classification. In 1931, roughly similar to Köppen, but more complex. Duplicacy, duplication in his efforts. When you are talking about thermal province, when you are talking about precipitation effectiveness index, that itself include temperature, then you are again finding out thermal effectiveness index. Right? Either humidity index or even thermal index will tell you about the rate of evaporation, and if you can quantify the moisture availability, then you can talk about it, right? So duplication, basically when we talk about potential evapotranspiration, it itself is a function of temperature and precipitation. Hence the division into thermal provinces and humidity provinces has increased the complexity. The classification has greatest application in water use planning and management, as it talks about the surplus, deficit, adequacy, and the requirement of moisture in the soil with respect to temperature. This makes it applicable in agriculture sector, urban planning, etc. Sorry? हाँ, इकोनॉमिक ज्योग्राफी में क्लाइमेट का he was basically convinced, you can write down please, he was basically convinced that soil moisture balance is the foundation of climate system. The foundation of climate system. Up to a great extent, he was true. Up to a great extent, he is true on this count. Yet the negligence of other factors apart from precipitation and temperature makes it less acceptable. It is basically a complex version of Köppen's classification. Next is Trevartha classification. He has used several formula. We have reduced that. Several formula to come to conclude that I is equal to function 9.8 into by 10t minus I into to the power a several 3, 4, 5 formula. There is no need to go for that because they will never ask you formula. Generally, the climatic classification will be asked about Köppen, Trevartha, rarely Thornthwaite. Thornthwaite, if they ask you simply present a classification of Thornthwaite because examiner do understand that presentation itself is so difficult. So criticism की बात आएगी तो वहाँ पे ये बात करेंगे, complexity की बात करेंगे by using that. Trevartha, again an American, latest classification, generally believed to be a modified version of Köppen. Last is 1980. Trevartha basically concluded the Trevartha was basically in the opinion of Trevartha has basic opinion that Thornthwaite and Queppen's classification Thornthwaite and Queppen's classification of the opinion that Thornthwaite and Queppen classification are based on certain statistical parameters of climatic elements and are cumbersome and more complex. The complexities and the large number of climatic regions make it difficult to remember and utilize. Make it difficult to remember and reduces its utility. Hence, he classified the world climate into 15 regions. But he further suggested that if required, subdivisions may be possible, but only by the experts. He suggested that a realistic presentation of climate should be the norm and the different categories, experts like botanists, agriculturalists, geographers, must not be forced for a preconceived genetic structure or a scheme of type of location or a scheme of type location. He was more in favor of empirical classification. However, did not deny the merits of genetic classification. Rather preferred a combination of both. He also used the two most important climatic elements, that is temperature and precipitation, for his classification. This way he was not different from Köppen and Pontovet. I'll have 5 minutes. His classification, just write. अच्छा कहाँ चले गए? हैं? सहारा डेजर्ट? हैं? सहारा डेजर्ट में? सहारा डेजर्ट स्नोफॉल के लिए है ही ये. That is, if at all it happens, it will happen in winter. It will be snowfall only. हैं? 1919 के बाद इस बार हुआ है.
1979 के बाद
Sahara desert में snowfall. The winter temperature would be very very low. कहाँ गए लोग? सब चले गए. हाँ? चलो लिख देते हैं, उतार लेंगे. Climatic regions based on temperature criteria. A. Tropical humid climate. B. AR, tropical wet climate. AW, tropical wet and dry climate. Then we have C, subtropical climate. CFW, subtropical humid climate. CS, subtropical dry summer. D, temperate climate. DO, temperate maritime climate. DC, temperate continental climate. Then E, boreal climate. F, polar climate. FT, tundra. FI, ice capped. Regions, climatic regions on precipitation criteria. B, dry climate. BW, the arid desert type. BS semi-arid steppe type. Then BWH further classified tropical, subtropical, hot deserts. BWK temperate, boreal, cold deserts. Then BSH tropical, boreal steppes. That's the classification of Trivarthas.
Same for wet and dry, common.
Tropical wet and dry climate. Wet and dry, that is within the year there are some period of seasonal wet and dry.
What is that?
BWH, tropical, subtropical, hot deserts.
So after the temperate climate, that's DD, temperate climate.
DO, temperate maritime, DC, temperate continental. Boreal? Boreal is basically the coniferous regions. Boreal is a type of forest.
And what is the difference between this polar, tundra and ice?
Polar is the tundra, I hope we understand. The continental areas which experience relatively lower temperature, but during summer the temperature is slightly on the higher side because of continentality. Then polar climate is somewhat where the freezing and thawing takes place, just above the tundra region. And ice-capped areas may be on the highlands also, let's say Siachen Glacier. Right? So in the tropical region, that's how he has included highland also, that ways. And he has not taken highland as a separate climate. Basically, he suggested that different height of a highland can be attributed with different types of climate. And that is somewhat true as well. Like in the mountainous region, somewhere you may have ice capped, somewhere you may have tundra climate, somewhere you may have tropical, subtropical nature of climate depending upon their latitudinal position.
So what is that coexistence of dry and dry and wet conditions together?
In our country itself, you have dry and wet conditions. During monsoon season, you have wet areas, and the rest of the time you have dry conditions. So wet and dry condition can coexist. That's where the deciduous forest will be found. Like what was the case of Koeppen's classification when he suggested AW? He suggested winter dry. He is using the tropical wet and dry. Right? He didn't specifically mention the summer dry and winter dry. That may be summer dry and winter wet, winter dry and summer wet. So seasonal variation in the rainfall. So what do you find here in classification when you compare with Koeppen's?
That is
Much
much more detailed.
more? The same is
It's kind of extension of
extension of Koeppen's, right? If you look at the even the letters used and symbol used is very much coexistence with the Koeppen's. And as far as extension is concerned, further extension is not there the way he has classified the continentality. He has differentiated between oceanic and continental, but only in the case of temperate climate, not in the case of tropical climate. Even in the tropical climate, the continentality and maritimity has a very strong impact. continental area of similar latitude will reflect a dissimilar climatic system or elements as compared to the maritime areas, oceanic areas. That only new introduction is the oceanic and continental. Maritimity and continentality he has introduced. Rest are almost similar to Kuapans.
He has also ignored AM and AS.
Monsoon types, both Thonthvet and Trevartha has AM type, monsoon type climate covers a much larger area. This is no more a local phenomena. Even if you take Indian subcontinent and some portion of Southeast Asia, that's a big region. Besides North America, Southeast Asia, some portion of China do experience monsoonal climate. So ignoring that is simply reflecting their own regional biasness about the climatic regions. Whereas Kuapans, since he was Russian born, then German climatologist, so he was of the opinion aware about the Southeast Asian condition, at least if not South Asian conditions. So he has introduced monsoon climate, rest of the two has not introduced.
Tropical wet and dry are somewhat the same.
Yes, same. But differentiating tropical wet and dry between winter dry and summer dry is a more better explanation and precise classification as compared to simply saying wet and dry conditions. So Trevartha's classification is just an extension of Kuapan's classification with some modification and some ignorance. तो अब अगर क्वेश्चन इस तरह से अगर ट्रेवार्था का आता है तो जनरली उसको क्वेपन से कंपेयर करने बोलता है. सो क्वेपन को आप याद रखिए और फिर ट्रेवार्था को याद रखिए, दोनों को कंपेयर कर दीजिए कहाँ कहाँ पे ये थोड़ा एक्सीड किया है, कहाँ कहाँ पे इसने क्वेपन को लेटर सिंबल सिमिलर है, रफली एक्सप्लेनेशन सिमिलर है, द कैरेक्टरिस्टिक्स ऑफ द क्लाइमेट इज सिमिलर. व्हेन यू से A is tropical humid climate and AR is tropical wet climate, it is completely irrational, isn't it? When you say humid and then you are saying tropical wet climate, what is the fundamental difference between it? Getting that point? No. Look at here D, temperate climate. When you are talking about temperate climate, that will include temperate maritime and temperate continental. So that is unnecessary extension of the similar type of climate by using more number of children. Right, this way it is more irrational. Look at here CFW. When subtropical climate, what is subtropical humid climate? Right, then subtropical dry summer. CS, that is Mediterranean, nothing but Mediterranean type of climate represented by Kuapan's CS climate. And subtropical dry summer is exclusive to that of Mediterranean. So Mediterranean climate. There is nothing subtropical dry climate. If you look at subtropical humid climate, so subtropical humid climate is western coast climate, where westerlies are onshore. So what do you mean by subtropical climate? Then that subtropical climate should be in the dry section, not in the wet section or the temperature provinces. The subtropical climate is the subtropical high pressure areas. Then subtropical wet humid climate will not be purely subtropical, rather western margin of the temperate climate. So this way it is more irrational as compared to even Thonthvet. Thonthvet has some utility with respect to a special water budget and all. Right, he talks about, similarly if you compare, so he has, Trevartha has also used temperature and precipitation as the two bases. Kuapan has also used, with a bit of modification, Thonthvet has used a similar thing. Thonthvet has introduced seasonal variation, that is one departure from the Kuapans and Trevartha. Kuapans talks about the precipitation effectiveness or potential evapotranspiration, which has much greater utility in vegetative explanation as compared to the simple precipitation and simple temperature explanation. But duplicacy is there in Thonthvet also. That's why even in the present day, Kuapan's classification has much greater application and acceptance as compared to Thonthvet and Trevartha. duplication plus irrational classification in many senses, leaving behind several microclimatic conditions. In the case of Thornthwaite and Koeppen, there are a scope that you can assign some microclimate also by using different symbols. Right? He has also used similar, like he is saying that there must not be ambiguity or a huge amount of complexity. Now, a complex natural phenomena cannot be over-generalized. As simple as that. Because climatic classification itself, initial discussions जो हम लोग लाए थे, उसको आप यहाँ पे ले आओ और उसके साथ इसको क्रिटिसिज्म करो.
But we have to give credit to them, so at the end.
हाँ, क्रेडिट तो कर देना ही देना है कि भाई पढ़े लिखे लोग हैं, हम भी पढ़े लिखे लोग हैं, तो थोड़ा सा उस तरह से दे देना है.
So how we'll end about it, sir?
एंड जब अब हम एंड की बात करेंगे तीनों क्लाइमेटिक क्लासिफिकेशन के लिए, जिसमें एक क्वेश्चन और बनता है विच आई एम एक्सपेक्टिंग बट हैज नॉट बीन आस्क्ड येट. राइट? लाइक devise your own method. Devise your own method to classify world climate. What are the possible tools and techniques you will use to classify? अब इसमें एक चीज आती है इसको आंसर करते वक्त, साइनोप्टिक क्लाइमेटोलॉजी. That is description of local and regional climate. That is synoptic. That's why the synoptic weather chart is the presently tools and techniques. First is the satellite imagery. Right? Application of modern climate stations, ships, radars, etc. Modern information about jet stream, atmospheric circulation, air masses, fronts, etc. Regional, intra-regional, regional and local variation in climate various methods to understand the past climate or paleoclimate. And then use of topoclimate and ecoclimate. Effect of local topography over climate of microorganism. Write down please. A holistic climatic classification. A holistic climatic classification should provide a system of pyramiding categories. Pyramiding categories ranging from the microclimates of small areas through mesoclimates, microclimates of small area through mesoclimates to highly generalized macroclimates on a world scale. The higher classification, that is macroclimatic regions, must be very generalized to understand the general pattern of climate of the world without giving too much emphasis on the intra-regional variations. The specialization must increase. The specialization and micro details must increase from meso to micro type of climate. Meso to micro type of climate. Which can incorporate topoclimates and ecoclimates as well. Topoclimate and ecoclimate. The exchanges of energy is maximum between the Earth's surface and atmosphere closest to the surface hence the microclimate cannot be generalized. sequence of a synoptic map, upper air chart, and vertical cross section can be the basis for classifying the regional climate and weather associated with it. The modern day has adequate records which was not there in the past. From geology, biology, archaeology, and the model tools and techniques, and the modern tools and techniques. Data, or the data available from modern tools and techniques, these all can be utilized to divide the similar climate into dissimilar regions, similar regions into dissimilar climates, similar regions into dissimilar climates. Besides, human interference must be treated as an integral part of this climatic elements, of the climatic elements, or as a climatic element to present a real picture at the meso and micro level. For example, the equatorial region in Amazon basin, Congo basin, and Indonesia and Malaysia reflect huge variation. At microclimate level. The subtropical deserts with respect to human activities differ a lot in different parts of the world. From the pygmies of Sahara to highly specialized and well-developed, pygmies of Sahara to highly specialized and well-developed, West Asia and American deserts. Similarly, the level of interference by humans vary in the mid latitudes as well. Where the climatic elements have interfered with human activities and humans have modified the elements itself. For example, Siberian region, humans have modified the elements itself. For example, Siberian region has least interference in the middle latitude. Whereas the Western Europe and Western Russia has the maximum interference. Has the maximum interference and modification of climate at micro level. Hence, any classification of the modern postmodern world, hence any classification of the postmodern world must include human as a separate active element. You can talk about carbon emission, ozone hole, global warming, deforestation, diversion of river channels into different parts, mining, all the activities of humans that has modified. A very good example of a topoclimate, Delhi ridge जानते हो यूनिवर्सिटी का जो Delhi ridge है, बरसात के टाइम में Delhi ridge एक पोर्शन है, Delhi यूनिवर्सिटी के बीच से गुजरता है, जो थोड़ा सा एलिवेटेड पोर्शन है, and you have good density of trees there. And if you roam around, you will find much higher amount of rainfall in that small area as compared to the nearby area. So Delhi will be treated as a single climatic zones, but you have huge amount of inter-regional variations, right? So eco-climate, topo-climate, synoptic climatology, all these should be a part. Earlier, अब हमारे पास क्या था? Data नहीं था, right? Older classification में अब data है. तो अब जब हम बात करेंगे तो specific climate की बात करेंगे, because we are dealing with the minute details of several activities. Like हम floods की बात करें, जैसे Thonthwet कहता है कि soil saturate हो जाएगा, तो उसके बाद जो है उसकी water holding capacity घट जाएगी, so that will lead to flood, right? That's just one very very small aspect of flood. If humans can, like Huanghe River used to be called as sorrow of China, now it is a boon for China through hydroelectricity generation, right? Interlinking of rivers in our country itself can really play a big role in modification of micro and mesoclimate. Imagine the role of Indira Gandhi Canal in Rajasthan area. That will be a very good example of modification. So unless until human is treated as a central part of the microclimate, specifically when we are talking about the purpose with respect to human activities, it will not be a complete classification. Even a very generalized climatic classification must have human as an element. However, they may be generalized, but microclimate must include humans as an integral part of it. Yeah? Thank you and take care.